All right, so we're in Journal 5 here, and we're going to take a look at solving this triangle here. So in this problem here for our bell work, it says that we are trying to write an expression or a formula, you can think of it, to calculate the third side of the triangle. So you have one side here, x, and another side here, y. You have to figure out what's this side here. Now, one way we can do this is what we learned in geometry a long time ago. It's called the Pythagorean theorem, right? If you have a triangle with a side, let me just write that down first. Pythagorean theorem. So basically, Pythagorean theorem is basically saying if you have a right triangle, has to be a right triangle, and let's call this AB, and then there's a hypotenuse, the long side, or the side that's diagonal from the right angle is what we call the hypotenuse, then you can you can find all the sides by using this formula, a squared plus b squared. So basically taking the legs of the right triangle, squaring them, adding them, and then that will give you c squared. So that's the Pythagorean theorem. And what we're going to do is use that, but we just have different variables here. So I'm going to call this mysterious side here R. Okay, I will explain why I'm going to call this R later on. It will have to do with something that we will learn in the next journal. But for now, I'm just going to call this hypotenuse side R. Okay, so now if I want to use the Pythagorean theorem, all I have to do is I can say that R squared is equal to x squared plus y squared, right? Because this side here is going to be the square or the sum of these two squared. So that's what I have here. But I want to solve for r. So what I have to do is try to get r by itself. There's a square here, so I have to get rid of that. So I'm going to take the square root of things. There we go. And so now that is going to cancel that square root, and the square will cancel with each other, bringing down just the r, and then we have the square root of x squared plus y squared. And so now that, while r is by itself, and so this formula is going to be our formula for this side here. Actually, let's go ahead and replace that. Let's grab my white eraser. So this is the square root of x squared plus y squared. Okay, so let's move on to our lesson for today. Okay, so let's talk about trig functions here. So we have seen sine, cosine, and tangent before, and I'll write those here. So this one is sine, cosine, tangent. We will talk about these here in a moment, but for now, let's just focus on this guy here. So when we're talking about trig functions, actually, let me scoot. Is there a way I can make this smaller? There we go. All right, perfect. Okay. So based off of this triangle here, I'm going to choose an angle, let's say right here. That's where I'm going to place theta, our angle. And so perhaps in geometry, you learn that using this angle as your orientation, this side here, the side that's opposite of this angle, right, is what we call the opposite side. Or that's right across from the angle. Whereas the side that's attached to the angle is what we call the adjacent side. And the side that's right directly or diagonal from the right angle here, the longest side, is always what we call the hypotenuse. Now, all these vocabs that I'm talking about is just exclusive for a right triangle. Okay, we're just working with right triangles. You might have also learned how to write ratios. So ratios for your sine, cosine, and tangent. And you might have learned this acronym called SOHCAHTOA. right? This helps us figure out which one goes on top and bottom for each trig function. So for sine, if we use SOHCAHTOA, sine is opposite over hypotenuse. So that's what it means. So opposite first, and then over hypotenuse. I'm just going to abbreviate to keep things short. I'm just going to do HYP. There we go. And so what I'm saying is that to figure out what sine is, using this angle, you have to choose the opposite first and divide that by the hypotenuse. So opposite over hypotenuse. Cosine is taking the adjacent, notice the A, so cosine C, adjacent A, H is hypotenuse. So this is going to be adjacent hypotenuse. And last but not least, TOA, opposite over adjacent. Okay, now that we've talked a little bit about sine, cosine, and tangent, we're going to talk about these trig functions, which basically are the reciprocal. So these are going to be our reciprocal. Let me see if I can grab another pen here. So actually, I don't want to do it in that color. Let's do blue. Or green, sorry. So these are going to be the reciprocal of each trig function. And if you remember what the word reciprocal means, it's basically when you have a fraction, you flip it. So all that's going to be is taking, let's see, the sine. So if I were to take sine, it's opposite over hypotenuse. Well, this guy here is called cosecant. Cosecant. I think that's how you spell it. And it is going to be the reciprocal, so it's going to be hypotenuse over opposite. And then our next one here, which is associated to cosine, is what we call the secant. And it is going to be the adjacent over, sorry, not adjacent, my bad. It's going to be the flipped, which is going to be hypotenuse over adjacent. And then last but not least, we have the cotangent. And the cotangent is associated to the tangent as the adjacent over the hypotenuse. Alrighty, so that's all your 6 different trig functions. We'll talk more about these later because you will need to be able to use them for your project later on. So let's do some example problems together. Okay, so in this problem, you can see that there is a triangle, a right triangle, and I'm going to go ahead and place that angle for you. I just haven't placed it yet. So I'm going to say that the angle theta is right here, okay? And my question is to you is to find all of the 6 trig ratios that we talked about. And so it might help you out if you write down SOHCAHTOA, so that way you know which one to start with. So SOHCAHTOA, C-A-H, and then TOA, O-A, TOA. So I'm going to use that to help me fill out my ratio. So sine is opposite over adjacent. Looking at this angle, opposite is the 3, right? And adjacent is the, opposite is the 3, and the hypotenuse here is the 5. So this is going to be 3 over 5. Cosine's the adjacent, right? Adjacent over hypotenuse, so 4 over 5. 4 over 5. And then tangent here is going to be the opposite over adjacent, so 3 over 4. 3 over 4. And so now, this part, the reciprocal trig identities, so cosecant, secant, and cotangent, is super easy because we just take the fraction of the sine, cosine, and tangent and flip it. So we're going to take sine, flip it, so that'll be 5 over 3. Take cosine, flip it, that's 5 over 4. And cotangent, if we flip it, we get 4 over 3. And we have all 6 trig identities. And that's it. So now, since we've gotten a little bit used to this, let's try our next example problem where not all the sides are there. So you're going to have to find one of the sides. All right, so second problem here. Notice how this triangle has 2 sides, but then this side here, I don't tell you what it is. So that means we have to find it. But first, let me make sure we set up this problem. I'm going to say that this angle theta is right here, and we're going to use that to pivot and find all the sides. So we have 12 and 9. How are we going to find this side here? Well, earlier in the bell work, we talked about the Pythagorean theorem, right? And we made this formula or this expression where we can reuse. And if you guys remember, it was basically saying that the hypotenuse, or R, and I know right now it's probably really weird that we're calling the hypotenuse R, but I will surely tell you what that means in our next journal, I promise. But I like to keep things suspenseful, so until then. So this was the formula we were using, and what we need to do is plug in our x's and y's, or two sides. So I'm going to plug in 12 and 9 into here. And so let me grab a different color, maybe green. Yeah, I'm feeling green. And so we have 9 squared plus 12 squared. Maybe I should put these in parentheses. It really doesn't matter, but I'll just be extra. Why not? So 9 squared is 81 plus 144. And 12 squared is 144. Add them together, you get about like 225. Take the square root of that, and that's 15. Now, you probably also learned in math that when you take the square root of something, you would have the positive value and the negative value. But here in Trig, you're only going to care about the positive value when you take a square root, because we only have positive lengths, okay? No negative lengths. So in this case here, we have all the sides now. So if I want the sine, oh, maybe I should write SOHCAHTOA just in case you guys need it. So I'll write that on the top. So remember, sine is opposite over hypotenuse. So let's go grab that. That's going to be, oh, sorry, that's supposed to be not my pen. There we go. 12 over 15. And then cosine is going to be 9 over 15, right? Adjacent over hypotenuse. And last but not least, our tangent, 12 over 9. 12 over 9. Oh, wait, hang on. Wait a minute. This fraction, these fractions here, they can be reduced, right? 12 and 15 are reducible because they could both be divided by 3. Let's go ahead and reduce them. Don't ever forget that. So fractions, make sure if you can reduce them, please do. So 12 and 15 can both be divided by 3. 12 divided by 3 is 4. And 15 divided by 3 is 5. 4 over 5 cannot be reduced. 3 divided by 9 is 3. And then 15 divided by 3 is 5. And then this one here be 4 over 3. All right, now that we've reduced them, and now we have to find the reciprocal trig functions. Well, that's going to be easy because we can just take the reduce and just flip them, right? Less work here. So let's take our reciprocal or take our functions and flip them. So that'll be 5 over 4 for cosecant since it's associated sine. Secant is associated cosine, so that's going to be 5 over 3. And cotangent, so 3 over 4. And then we are done. Nice, guys. All right, one more slide. Okay, last problem. So this one here, I got no triangles for you, okay? This time around, I give you a trig function and its trig ratio, and that's all. And from there, you have to tell me all the other trig function or the other trig ratios that we have, right? So if I already have sine, you got to find the other 5. But how in the world do we do it? We don't have triangles. Okay, let's think for a sec. This trig function, what do we know about sine? Sine is opposite over hypotenuse. That's what we know. So let's think about it. If we have those pieces, it's actually that the case is we know 2 sides of this triangle. So let's make a triangle, is what I'm saying. All right, so we're going to build ourselves a triangle. It's a right triangle. And so this side here, let's just say that that's going to be our theta that we're pivoting off. So as long as we use the correct, like if this is theta And 5 is your opposite. You got to place 5 opposite of theta. So this has to be 5. And then 13 is our hypotenuse, so it needs to be on the long side. And now we just have to figure out what this, let's call this here mysterious x that we need to figure out. Well, how do we do that, right? So first we learned this, we made the Pythagorean theorem formula, way earlier. So remember that formula, the Pythagorean theorem, is just r squared. So let's write that here, r squared equals x squared plus y squared, where r squared is your hypotenuse, right? And we know the hypotenuse, which is 13, so why not plug it in? So 13 squared equals x squared. We don't know x, right? But we do know the other side. So the other side is 5, and so we have to square that. And so now it's just a matter of solving for this x, getting it by itself. So let's go ahead and square both sides. So 13 squared is like 169. X squared brought down, 5 squared, that's easy, just 25, right? All right, so now we're going to try to get that x by itself. Maybe do some fancy subtracting, right? Subtract that 25 off. This cancels. We bring down the x squared. And now we have, well, 169 minus 25 is 144. Ooh, that's a nice number. So now we can try to get rid of the square by square rooting both sides. And that would bring us to x. And the square root of 144 is 12. And so now we have our x. That means this puzzle right here is 12. Okay, we got our triangle completed. Now we got to go find the other trig functions, right? Because we only know sine. Sine is 5 over 13, but we need cosine. So cosine is going to be, let's see, this angle adjacent. Well, that's just 12 over 13. Easy. 12 over 13. And then if I want tangent, right? Tangent's going to be 5 over 12 opposite over adjacent. And doesn't look like I can reduce any of these, so I'll just keep them as they are. Leave them be. And then we need our cosecant here. So our cosecant's the one that's reciprocal to sine, so flip. So 13 over 5. Then we got our secant angle and flip. That'll be 13 over 12. And then last but not least, the cotangent, which is going to be 12 over 5 if we flip that tangent. And that's it for you guys. We got our trig identities here, all 6 of them. And so this problem here, anytime you're given a trig ratio, know that that ratio contains 2 sides of the triangle. So you can find that third piece using the Pythagorean theorem. I hope that makes sense. And as for homework, there is no homework for this section. I really just wanted to review some trig identity rules with you guys. So pretty simple day, but you need to know these 6 because we are going to do a project where you have to find a right triangle and you'll be able to measure 2 sides, but maybe you're not able to measure the third side. And from that, you have to create the ratios for all 6 of them, okay? That rubric for the project is on that Google Classroom, on that spreadsheet. If you need help finding it, let me know, and I'll direct you in the right area. So that project is due next Wednesday, September the 11th, okay? All right, that's all for this video. Have a great day, guys.